section 3.2, and then we're going to take our homework quiz. Before we get started on that, do you guys have questions on things? Go ahead. Huh? You give me something specific.
How about like one of the like construction extensions on like where's it? Number sheet 2. I don't know which one. Can we do like it's worksheet 2, number 7.
All right, number 7 here. Says find the equation of the sinusoid that has a minimum value at 3,0 and a maximum value at 2320. So if I kind of take a drawing here, I have like that. Okay with that? Agreed? The midway there, well, between 20 and 0 is got to be 10, right? So that tells me the value for the absolute value of A and my value for K, right? If 10 is the place in between 0 and 20, and then you have 10 units from that midline to the extrema, that's the K and the A. You could also do that with the formulas that I gave you. Either way of doing it is fine. I like doing this because I probably won't screw that up and I might get which one is mixed up, you know. But this I got. All right, next thing I want to do is come up with the period. If I were to draw one full period, I'd have to go back down to a minimum, right? This looks like about half. So I know half a period is going from 3 to 23, which is 20. So one period is 40. And I know a period is 2 pi times the absolute value of C. So C is going to be 20 over pi or negative 20 over pi. And we're always going to pick the positive option for C. So last thing we need to do is decide which function do I want to write, sine or cosine, because I have a choice, and then figure out the value for H and the sign for A. Which one would you use? Cosine, very good, because the values I'm given in the problem are extrema. So we're going to use a cosine function here. So from the parent function, I'm going to use the point 0, 1. And I'm going to be, which is a maximum. And then I can map it to either of the 2 points. It doesn't matter since they're both extrema. I'll just use the first one, which we're told is a minimum. Since these are opposite types of extrema, that tells me the A is negative. So we need negative 10 for A. And since the x-coordinate from the parent function is a 0, the x-coordinate on the transformed function is just my value for H. And that's all we need. No, they can both give you the correct answer, although the answers would both be different.
Yeah, okay.
But you could use either one.
Okay. You only have to do one.
Yeah, one answer is fine.
Yeah, I didn't know that.
On the key, I put like all the possible versions that you could have answered, and depending on how you did it, so that you'd be like, oh, I got the wrong answer. No, one of the answers is there. Allie, what's up?
This is like a basic question, but like when you said use cosine because the extreme of one, would you assign? Like what's
an example?
If I had a midpoint,
Oh.
I could use sine.
Okay.
Or if I was just told it's any old point on the function, like in problems, like 1, 2, 3, etc., where just passing through some point, I can kind of decide where I want to put that point on the graph, or like in relation to the graph, then I would use sine. All right. Section 3.2, we're going to be doing the exact same thing, except we're going to be talking about the tangent function. So it's all the same ideas, all the same techniques. Everything kind of works the same-ish way. And just like when we did sine and cosine, we're going to start by coming up with the graph for our tangent function. All right. So remember that on the unit circle, tangent is y over x, right? So if I do tangent of 0 radians, that's going to be 0 over 1. What's 0 over 1? 0. Okay, and then I do tangent of pi over 6 should be 1/2 over square root 3 over 2, which is, the decimal is 0.577. And then pi over 4, and I have root 2 over 2 divided by root 2 over 2, so that's just 1. I have pi over 3, and then I have square root 3 over 2 divided by 1/2, that's just the square root of 3, which is 1.37. And then pi over 2 is going to be 1 over 0. What is that? Undefined. What is that going to look like on my graph? It's going to be an asymptote, a vertical asymptote. So let's put that in. Mr. Kulik, when I draw mine, do I need to include the asymptotes? Oh, yeah. And I'm just going to kind of continue going here. Filling this in. It's all kind of working the same way here. Right? Anybody with questions about how I'm getting these values? Just doing it the same way. And then when I get to 3 pi over 2, I'm going to get another vertical asymptote, right? Let's make that red again, just like the other one. And dashed. Okay, and then we'll have 5 pi over 3. And then that'll be negative square root 3, 7 pi over 4, 4. That'll be negative 1. We'll have 11 pi over 6. That's negative 0.577. And then we'll have 2 pi and 0. And that's one full circle through the, or one full guy through the unit circle. What are you noticing here? Is this repeating?
Yeah.
Yeah, sure. How often is it repeating, though?
Yeah.
If I'm going from half a pi to 1.5 pi, 1 pi, the fundamental period here is different, huh? Ooh, interesting. Let's drop that guy in there. So here's our graph for the tangent function. So the period we saw was pi. What's that going to mean for the transformation? For the general form? What do you guys think? This can be pi times absolute value c. Don't be shy. It's the same thing as before, right? What's the only difference? It's pi instead of 2 pi, and that's just because the fundamental period for tangent is pi instead of 2 pi. Oh, all right, whatever. What else do we talk about? We talk about the amplitude, right? Now, is there an amplitude based on our definition on this one? No, why not? Because there's no extrema, right? This has no maximum or minimum values because we have arrows pointing up and down in both directions, correct? Okay, well, stop talking, please. What's going to act like our amplitude? Oh, we should have done midline first. Why didn't I do that first, Mr. Kulak? Let's take a pause on amplitude and talk about the midline. Where's the midline at? Yeah, still y equals 0, right? So in the transformation then, the midline will still just be y equals k. And the amplitude then, go back to that conversation we just had a minute ago, or we're trying to have a minute ago. We don't really have an amplitude, right? But that a coefficient still is affecting something. This is what it's kind of affecting. So it's that distance. So that point is like between the midline and the asymptote. That's like halfway. The distance from that point that's halfway between the midline point and the asymptote back to the midline, that's like our amplitude. Is everybody okay with that? That's going to kind of be what it means. But strictly speaking, the amplitude does not exist. That's the letters D and E capitalized, short for does not exist. When I wrote this fourth period, someone asked me why I was spelling 1 there. And it's like, boy, that says something about my penmanship. But those are the letters D and E for does not exist. That's why they're all capitalized instead of lowercase. All right. We notice that tangent also has an additional key feature that neither the graphs of sine or cosine have. Namely, we have these asymptotes happening periodically, right? Where are those asymptotes happening? How many asymptotes am I going to have? Let's start there. Infinitely many, right? How far apart is each asymptote? Pi units, right? So what I'm going to do is I'm going to describe the location of one of these asymptotes, say maybe this one at pi over 2. And then every pi, oops, that's supposed to be a 2 down there. Or every multiple of pi after that is going to be another asymptote, right? Whether I add 1 pi or 2 pi or 10 pi or minus 56 pi, those all land on an asymptote, provided that that n is an integer. Now this simplifies to just like n pi over 2, where n is an odd number. So oftentimes we'd write it that way. But it's a little bit easier to kind of see what's going on. I'm not going to be here on this day to give this, so I don't.
Is she here right now?
Oh, this person is
so
absent.
okay, got it.
Sorry,
Thank
I
you.
thought you were trying to give me my instructions.
No, they just forgot to hand them out during community time, so I'm going through.
I see. My apologies.
Thank you.
You're welcome. Good luck tracking them down.
Thanks. Oh yeah, Mr. Emerson didn't hand them out. I asked him for mine, and he was like, "Yeah, I didn't hand them out." I was like, "Oh, we're supposed to." But...
Now, if I go to this one, if I go to the transformation, what parts of the transformation can affect the location of that asymptote? A shift left or right. Everybody agree with that? So if I've shifted the graph left or right by h units, the location of the asymptote is going to shift as well. Everybody agree with that? Okay. And how often will those asymptotes occur? My period is now pi times the absolute value of c. And then every whole number multiple of that will be an asymptote. Everybody's okay with that? So I took this and factored in the horizontal translation, and I took that and factored in the change in period. Everybody's okay with that? Okay. So if I wanted to graph one of these dudes, we would do this the same way that we've done before. So I'd start by identifying my values for A, C, H, and K. To do that, I got to write this in the general form. So if I do that, I have -3 tangent of 1 over 2 x minus 0 plus 0. So my A is -3, my C is 1/2, my H is 0, and my K is 0. So that's going to allow me to write my transformation map. So where I take a point from my parent function and transform it to a point on my resultant function by using the map cx plus h, comma ay plus k, which if you haven't memorized that by now, you definitely want to get on that. It's like the fourth or fifth type of problem where we've had to use this to do something, right? And now I just need my key points for tangent. If I go to my reference point sheet, those are my key points for tangent. I'm just going to copy those down. You don't have to memorize those. Those would be something that I would provide for you. So we have -pi/2 undefined. UND stands for undefined. -pi/4 comma -1. 0, 0. pi/4 +1, and then pi/2 comma undefined. So -pi/2 times 1/2 is pi over 4. Undefined times negative 3 is just undefined still. Negative pi over 4 times 1/2 is negative pi over 8. Negative 1 times negative 3 is 3. 1/2 times 0 is 0. Negative 3 times 0 is 0. Pi over 4 times 1/2 is pi over 8. And negative 3 times 1 is negative 3. And then 1/2 times pi over 2 is pi over 4. Anything times undefined is still undefined. Okay, so let's go ahead and graph this. The typical window I'd graph this is from negative 2 pi to positive 2 pi. So I'm going to go by eighths. So 0, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then keep on going. 1, 2, 3, 4, 5, 6, 7, 8. One, 2, 3, 4, 5, 6, 7, 8. All right. Let's start plotting here. So I have negative pi over 4 is undefined. So there's my asymptote here. Note that I'm putting in the dashed line. And then I have negative pi over 8 and 3. 1, 2, 3. 0, 0. Positive pi over 3, negative 3. So 1, 2, 3 down. And then an asymptote. I'm going to connect my graph now. Whoop. And then it's just going to be repeating the same thing. Over and over again. Oops, I got a little off. Is everybody okay with this? Does it look exactly like what we did before? It should, right? Here, guess I'll do this. The extension I'll do in blue. The tans are kind of hard to draw with dotted lines, right? All right, keep on going. So this side, negative 3, 0, and then that. And then negative 3, 0, oops, there. Negative 3, 0, and then there. Negative 3, 0. And we'll just draw in the rest of that. Whoop. 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 There's my graph for tangent. Yes. Sure.
This is probably dumb, but so you see that, like, okay, y equals tangent of 1 over c, and then you say 1 over c is 1/2, but then you say c is 1/2?
Oh, sorry. C is 2, huh? Yep. You fooled. You got me. I goofed that up. Here. I'm just going to change the problem so what we did was correct. There you go. Thank you. Yeah, I goofed that up. Let's do that. That'll be way less changing for everybody involved, right? Next time you see me doing something dumb, interrupt. Feel free. Just be like, hey, Mr. Kulik, hold on. and I'd be happy to stop. No worries. Katie,
What is it? How much is each dash?
how far apart are they?
Like how much does it go up by?
Oh, we're going by quarter or eighths of pi.
And they're but like how are there? How is the first one at 8?
Well, okay, sorry. Are you asking for the tick marks on the x-axis or the space between the asymptotes?
Yeah, the it's like if it starts at negative pi over 8 and then goes to negative pi over
So I started here, which is this spot, which is 2/8,
oh.
and then I went to here, which is 1/8.
So what would be like 1 over negative? Like on the other side.
I'm sorry, what?
Like wouldn't that be negative pi over 2?
This is 2/8, right?
Yeah.
Is that okay?
Yeah.
Okay. You're good?
Yeah.
I did it right? Okay. I made one mistake. It's not out of the range of possibility to make two. I just want to make sure we're all going. Yeah.
For the graph, are you gonna give us like the pi 2 and then pi over 2 and then like that stuff on the x-axis? Or are you just giving us pi 2, pi 3, pi 4, pi?
When you're talking about the picture,
Yeah, like when you graph it.
it'll look like on a test or whatever,
Yeah.
it'll look like the worksheets
Okay.
where I'll have a grid in there, laid in there with it partially labeled for you.
Okay.
You may have to add some more tick marks in, but it'll be partially labeled already for you. Is that good? All right. Everybody's cool with this though, right? No big deal. Same process as before, right? If you could do it before, you can do it again. Just takes a little bit of extra practice. What if we want to go from graph back to equation? Bless you. Let's grab an example of that. Let's see here. There's one. All right. So here we're going to go from a graph of tangent back to the equation. We're going to do this basically the same way that we did before, right? What do I like to start with? Finding the midline, right? Where does the midline look like? Looks like that, right? So that tells me the value for K. The next thing we're going to do is look, yes. Sure. The next thing we'll look for is the amplitude, or the thing that kind of acts like the amplitude. So that's going to be looking at the distance between this point that's midway between the midline point and the asymptote, and looking at that distance back to the midline. How far is that? 1 unit. So that tells me A is 1 or -1. Everybody's cool? The period, well, the easiest thing to do is just look at the distance between the asymptotes. So how far is it from -4 or negative pi over 4 to positive pi over 4? It's a half a pi, right? But remember, the period for tangent is pi times c. So c in this case should be 1/2 or -1/2. But we always like to just choose c to be positive. So far, so good? All right. The last thing we need to do is to figure out the values for h and the sign for a. So I'm going to pick a point from my parent function and use my transformation map to figure that stuff out. So if I look at my reference points, which of these points from tangent do you suppose I want? Yeah, we'd want to use 0, 0. Note that that's a midline point. And before that midline point, we're pointing down. After that midline point, the graph is pointing up. Right? If you just look at the y coordinates, they start negative, midline, and then they get positive. Everybody agree with that? Okay. So I'll just note that here. So I'll pick some other midline point from my graph. Any of those would be okay. Which one do you suppose Mr. Kulik's going to use? We use 0, -1. Note there that this is a midline point that prior to it, it's pointing, or the left side of it's pointing down and the right side's pointing up. Same kind of midline point tells me that the y or the a value is positive. God bless you. And then since the x coordinate on my parent function is 0, the x coordinate in my transform function is just going to be my h. And I got everything I need now. What do you guys think? Basically still the same thing, right? Not a big difference. That's everything I needed to do today. For next time, I'm going to just steal what I wrote down from before because, well, it took me a long time to come up with getting it in the right spot. Oh, come on now.